Hello, welcome back to the channel. In the last video, we talked about how you can set up Java and Java, JDK, and ID on a computer system. In this video, we're going to be diving into the core concept of Java programming by exploring variables, data types, and data type. So it's actually very important to know that this concept is crucial as they lay the foundation for everything we're going to do in Java. So without any further introduction, let's begin. Variables are actually containers. Just see it as container for storing data type, storing data, and actually assign different data types. So imagine variables as labeled boxes where we can store different type of information, content, or in it. So the content in it is data type help us to determine what content is in a particular variable. So that's just the relation between variables and data type. Variables is a container that stores the data, while data type tell us or tells us what content or what value is in the variable basically. So in Java there are there are naming conventions we need to follow. One which is it's important that you use a meaningful name, starting with lower cases, using use of common case, just like this, number, name of student, avoid underscores, or different programming language like Python that uses underscore while defining your variable name. To avoid pre-reserved words as well. So this seems like some of the important naming convention that for a start you need to know here. So as I said before, data type define the type of data that can be stored in the variable. Basically, just as simple as that. So we have different data type. We have data type in Java are divided into primitive type and non-primitive type. For primitive type, divided into Boolean type and numeric type. Boolean type are just basically true or false, 0 and 1. Numeric type are divided into character, integer, and character is just char in Java. So why is character a numeric type? So basically every character has an equivalent value, numeric value, ASCII in the ASCII value. So integer values are divided into integer and floating point value. Integer basically has byte, short, int and long. These are all integer values with different sizes, and the floating point value, which is the decimal value, are just the float and the double. So non-primitive on the reference data type are string, arrays, or class type, etc. So just to tell us the difference between primitive and non-primitive data type. Primitive data type stores their value directly in the memory. So typically, on the stack basically. In why the non-primitive data type basically or which are also known by reference type stores the reference to the object in the stack and the actual object in the heap um, of the Java virtual machine basically. Hello, so I've created a new Java project named Learn Java. So basically this boilerplate project only has one class file and only with what this printing out to the console hello world. So I'm just going to go ahead to show you how these primitive type are declared in Java. So for example, we're going to start with the boolean type. The boolean type to define it boolean type is a keyword called boolean basically in Java. They can use say maybe is student, check if someone is a student, or ask if someone is a student. So I say true when but by default we always have true or false. The default value is always default value is false, and actually just boolean type are 1 bit in terms of size. They're also 1 bit in terms of size. I mean, 1 bit, zero, basically zero or one. Yep. So boolean values are true, either true or false, with the size 1 bit, and with zero. Only the computer actually understands it as 0 or 1, basically. So the numeric type, which is numeric type, the numeric type, we have char, which is defined with character. Basically, this is what we call variable. Just to reiterate, this is what we call variable. This is what they call the type. The type. The type, I've said, it's what defines the variable, or what tells us what the variable contains, basically. And variables are just containers holding this value, and this is saying, oh, this is a type of boolean, so which is fine. So I'm going to say char a, and just going to hold the a. So char characters are defined using a single quote, and it has the size. In terms of the size, it's actually 16 bits. I mean, more like 2 bytes, basically. That's 2 bytes, and it ranges from, I think, 0 to 65535, basically. Yeah. So we have the type of the numeric type. Then we have the int. Let's start with a byte, for example. Byte. Let's say b is an integer value. So b can be 248, and basically it's actually just an 8-bit in size, 8 bits in size, and it ranges from 128 minus 128. So integer values are both negative and positive values. So minus 128 to 2127. So let's imagine that you want to store a value be above 127. Then the compiler, the IDE, is smart enough to tell you that, oh, this value is more than the range, basically. So if you could look at this error, it says it requires a byte, but you're providing an int. But because a value that is above 127 can actually be an integer value or int value. So for this, I'll just return it back to, let's give it 60. So we have the int value, the integer value, or let me use the short first. We have the short. I'm trying to start based on the sizes. The short value, for example, give it 120 or something like this, and the short value is also a kind of a 16-bit value. Its range is from minus 32 768 to 32 767, basically. So what this is telling us that if you try to store a value outside of this range, it's going to complain. Imagine doing the same thing for this. Let's say 232767 or 768 in this case for short, and it's just one value above the max value. Yeah, so it's just stating that, oh, this value you're passing to a short, it's beyond its capacity, basically. When you have a container, a variable, a container, and you fill it up with overfill it, it's actually going to cause an overflow or something. So it's better to, when you're using data type, it's important to know the ranges or the sizes as well. So I'm going to say the by integer value, going to integer now. The integer value, let's say I, and let's just give, let me just give it value, then random value, then the size of this is 32, that's why it's 32 a bit in size, and it ranges from minus 214 2147 483 648 to almost the same thing, 214, the positive side, 2147 483 647. So if you set the value of an integer, it is beyond this value. Oh, let me copy this and say, okay, I'm gonna set the value to this with +1, and it said, oh, you're trying to pass the integer value, integer number is too large, basically. So this integer has a max size, so you can only take a 32-bit value. So it's important that we know this before we it's important we know the type of data we're trying to save. That will help us determine type of the data type to use, basically. And we have the long value. The long value is actually, let me, so if I actually just copy this and paste it here with 8, it says integer is too long. So basically, let me tell you what this is. It's a long value is 64 bit in size. That's 8 bytes, and the value for long, I'm just gonna copy that out from here. The value for long is this. So you have over 99223372036 854. So this seems to be like a very long value for long. And so let me try to see, okay, why I copy this and say 7 or 8. So why did you not take it? Yep. So the other way is to let this know that, to let the ID know that this is a long value and not an integer value. So by default, every value is an int. That's why when you try to, when trying to use the max value for short, for example, it says you provided short, but you provided integer but require short. So it by default all the values are int, and to specifically define a long value, basically, that we need to put L value, the letter L, to tell the ID that, oh, this is a long value. So save the value as a long value. Also, we have the float value. The float, now we are now in the floating point value now. So so we have floating point value, for example, 2.5 is a floating point value. This is saying us that, oh, you're signing a double. So by default, again, every decimal value are double. So to define this as a floating point value, you just need to append the f to it, and that will be sufficient. That will tell the ID that this is a floating point value. So it's also a 2-bit value, which is equivalent to 8 bytes. The size of a floating point value is just going to put an approximate value around that. So which is very quite large. So also double value, you have to double the, and say, okay, put the value 0.25 or something. Then we didn't complain about it because by default the values are double, and this is also a 64-bit value, which is equivalent to 8 bytes. So 32 is equivalent to 4 bytes basically, and has a very large value. I'm just going to do a copy and paste there. Yeah, this is the value for a double. Okay, I think that covers the primitive type. So just to talk about the non-primitive type, non-primitive types. So non-primitive type, for first example, it's a particular string, a value that's in the code, in double quotes. For example, we have my name. Say, oh, name is okay, Hassan. So now this value here, we have a string, and we define it. This basically what the string is. If any value that's in the code to the string, which is different from the character with a single quote. And we have other type like an array. Imagine you have an integer, or let me say, you can just have a string array. Maybe you have a string array called, oh, these are names of people or names of dog. So you have this guy and say, oh, this is an integer. What it does, it has names of people, say Hassan, and as John, and so on. So you can this an array. What we know about an array, we're going to discuss it in depth in the future video. But basically an array just contains a list of values or list of string or list of whatever I want to store in it. So I think that actually covers what variable and what numeric type, what primitive type, data type, and non-primitive is. So basically, in the next video, we start to look at conversion from one data type to another. Imagine you have a value that is short that you want to convert it to a long. So what are you going to do? How are we going to do it? So in the next video, we're going to talk about typecasting, changing from one type data type to another. So thanks for watching. Hope to see you in the next video. Bye.